Hello, good day. Here we're going to look at logarithm and the laws of logarithm. We're going to state uh, the laws, then we provide the necessary proofs to them. Okay, first and foremost, let's look at what logarithm is. You know, from simple definition. Now, the logarithm of a number is a power to which the base must be raised, to give that number. Okay. Now let's look at this. We have a log x to base a. Now the x is the number whose logarithm is to be determined, while a here is referred to as the base. Okay. Now from the simple explanation here, like I said, that the logarithm of any number is the powers to which the base must be raised to give that number. Okay, now we'll come to that later. Now let's look at the laws of logarithm. Okay, one of the law here, number one, if you have a logarithm of a number, okay, and the base are the same, okay, but the operation sign here is addition, which is plus. Okay, all you need to do, like we have here, log x to base a plus log y to base a is equals to log x times y to base a. Okay, what it simply means that once you are given logarithm, and so long the base are the same, and the operation sign here is addition, you take the base as a common base and you multiply. So addition will multiply. That is the first law there. Then law number two here, we have a situation if the base are the same and the operation sign here is negative. All you need to do, you take the logarithm to base a, the x divide by y. Okay, so the x here will usually divide y. Okay, that is the principle. Then the law number three has to do with if a logarithm to a particular base, that is logarithm of a number to a particular base, if they have the same the logarithm and the base, they are the same, the answer is exactly one. Okay, that is number three. Then number four, if we have a logarithm of a number, logarithm of 1 to any base, logarithm of 1 to any base, the result is usually 0. Okay, then if we have a logarithm of a number, let's say x raised to the power of let's say n. Okay, yes, now this logarithm can also be expressed as the power times the whole logarithm here. Okay, so that is number 5. Then number 6, if we have log x to base a, okay, this is what we call the change of base. We call this one what? Change of base. So in change of base, we could simply say that if we have change of base, okay, now once we have a logarithm of this nature, we can change it to another base. Okay, we can change it to another base, let's say c. So this logarithm can be transformed to log x base c divide log a base c. This is change of base. Then finally, which is number 7, if you have a logarithm, that is a power, and the base of a logarithm, if they are the same, the result of that logarithm is exactly the number to which you are to find. That is the number to be determined. Okay, so that's the logarithm of the number to be determined become the result. Okay, now what we're going to look at here, we serve I said from definition that the logarithm of a number is the power to which the base must be raised to give that given number. Now let's have this. If we have, for instance, if log x to base a is equal to n, from our definition, it is simply means that x, the simple definition is that x is equal to a raised to the power of n. This is just the simple definition of logarithm. Okay, so x now is equal to a raised to the power of n. So the n here is the result of the logarithm to be determined. Okay, now let's look at this table here. This is log x to base a, this is power, and this is n. Okay, now we have a log 27 to base 3. Now we spread this one in form of power. Logarithm, another word for logarithm is also power. Okay, here we see 27. How many times do we multiply this, the base, to give us this number, to give us 27? It's 3 times. 1, 2, 3, which is 3 raised to power 3. So this one simply means, this one simply means this simply means 3 raised to the power of 3. Okay, so our interest here is just this power here. So here you can see that the logarithm here is n, which is the 3. Okay, now similarly we have log 125 to base 5. Here, how many times does the base, which is 5, multiply itself to give 125? It's 3 times. 5 times 5 times 5 in 3 places we give 125. So therefore log 125 to base 5 is 3. Similarly, log 16 to base 2. How many times does 2 multiply itself to give 16? Is 4 times. So that means log 16 to base 2 is 4. Okay. Similarly, 49, log 49 to base 7. How many times does 7 multiply itself to give 49? Is 2. That means the logarithm of 49 to base 7 is 2. Okay. Finally, we have log 144 to base 12. You see, how many times does 12 multiply itself to give 144? Is twice. So that means log 144 to base 12 is simply just 2. Okay. Now we will see how we will show the proofs, or the proofs of logarithm. Okay. Here we have that the first law there, we said that log x to base a plus log y to base a is equal to log s times y to base a. Now we will use the right hand side to show that they are is equal to the left hand side. Okay. Now what we're going to do here, we say suppose, or we say let log x to base a is equal to u, and similarly log y to base a is equal to v. Okay, from definition we can now see that we can simply say that x is equal to a raised to the power of u, and similarly y is equal to a raised to the power of v. Okay, now because we are using the right hand side, which says that log x times y to base a, so in place of x, we will substitute a raised to the power of u, and in place of y, we will substitute a raised to the power of v. Okay, and if that is done here, you could see clearly here that log x times y to base a is equal to log a, open bracket, a raised to the power of u times a raised to the power of v. And you know from indices, if the base are the same and the basic operation sign here is multiplication, since the base are the same, all you need to do, you just pick the base, one of the base, and you add the powers. So from here this expression here becomes a raised to the power of u plus v. And eventually, if this is substituted, this becomes log a, open bracket, a raised to the power of u plus v, and this become you see that this is now power. Okay, this is now power, a raised to the power of u plus v. And we said here from log, one of the laws here, that once we have a power here, the power has to be what? Transformed back, and it has to act as a product. So u plus v will has to be transformed as power back here. But you also recall here clearly that log AA is eventually 1. So here log AA is eventually 1. That means u plus v times 1 is equal to u plus v. But what is u and v initially, because we have said that let the whole of this one, the whole of log x to base a is equal to u, and log y to base a is equal to v. So if we substitute this back into our equation here, you see that the left hand side is equivalent to the right hand side. So that proof as is shown. Now let's quickly look at the number 2. We said log x base a minus log y base a is equal to log s divided by y all to base a. So we use the same approach here. We will use the right hand side here to show that it is equivalent to the left hand side. Okay, by so doing, because we have already shown it previously that log s base a is equal to u, and we've also known that s is equal to a raised to the power of u, and y is equal to what? A raised to the power of v. If this is substituted on the right hand side here, which is this, on the right hand side, the expression become log a raised to the power of u divide a raised to the power of v. And we all know from indices that once the base are the same and the basic operation there is division, we take the base as 1 and subtract the power or indices. Okay, and if that is done, this become log AA raised to the power of u minus v. Similarly, we transform u minus v back. Here this becomes u minus v log AA. We have already know that log AA is 1, so this becomes u minus v times 1 is equal to u minus v. And we also know that u is equivalent to log x to base a, and v is equal to log y to base a. And if that is done, you will now discover that the left hand side is equal to the right hand side. That has been shown. Okay, let's move on. Let's show that log AA is equal to 1. Okay, we'll now say let or suppose that log x to base a is equal to u. Okay, from definition we cannot say that a is equal to a raised to the power of u. So that here this a raised to the power of 1, this is a raised to the power of 1 is equal to a raised to the power of u. So that if we equate the powers, you discover, you now find out that u is equal to 1. Therefore, log AA is equal to 1. Now let's now show that log 1 to any base is equal to 0. Let's quickly show that. Now we're going to say let or suppose that log 1 to base a is equal to v. Okay, I mean from definition, it means that this base here we move this way, and it will now become 1 is equal to a raised to the power of v. Okay, but you recall that this one here on the left hand side can also be written in this form, that is a raised to power 0 is equal to 1, since the right hand side as a base of a. Okay, so the left hand side can be replaced with a raised to the power 0, so that a raised to the power 0 is equal to a raised to the power v. Now, if we now equate powers, you see that v is equal to what? 0. Therefore, log 1 to base a is equal to 0. So log 1 to any base is usually what? 0. Now let's prove log x raised to the power n to base a is equal to n log x to base a. Now what we need to do here, we say let u is equal to log x to base a. Then, because we have already defined that x is equal to a raised to the power of u previously. Okay, so in place of x, we replace it with a raised to the power of u. Okay, so you put a raised to the power of u in place of x in log x raised to the power n to base a. And if that is done, you will see that this becomes log u raised to the power n u, okay, log then u times n. Okay, then you move u times n backwards, observing one of the laws that say that if we have the power have to be transformed back and multiply the logarithm. So it becomes u times n is equal to log a. Remember that log a is 1. So this becomes u times n. Now you have to reflect back. What is u? U is log x to base a. So we have been able to use this one to show that the left hand side is equal to the right hand side. Now let's go to change of base. That is log 6 log x to base a is equal to log x to base c is divide log a to base c. Now this is what we call change of base. Now suppose, like we have always said, that let's log x to base a is equal to u. Then x is equal to a raised to the power of u. Okay, if s is equal to a raised to the power of u, now because we are trying to obtain another logarithm to another base, so we say that we take log of both sides to a new base, in this case c. Okay, say c, so it becomes log, if we do that to this this equation on both sides, this becomes log x to base c is equal to log a raised to power u to base c. Then u here become a power, and we have to transform it backward, and this log, then log a raised to power u base c can be expressed as u log a to base c. So, and if that is done, we have a log x to base c is equal to u log a to base c. Then we are looking for u. Okay, then how do we obtain u? Because initially we said that let log x to base a is equal to u. Then we have to divide both sides by log a, a to base c. And if that is done, you will now find out that u eventually become log x to base c divide log a to base what? C. But if, for instance, that we now assume the base to be x, for instance, then we cannot say u is equal to log. So in place of assuming we are saying the base is x, for instance, this become log sx divide log a to base x. So this become 1 all over log a to base x. So this is change of base. Then the very last one here is if we have a power, we have an expression of this form, a raised to the power of log x to base a. Okay, because I said it is equal to s, then we want to show clearly here that this expression on the right hand side of the left hand side is the same thing as that of the right hand side. So we suppose that the whole of this expression here is equal to u. Then for us to fulfill this purpose, we must consider the logarithm, the base of the logarithm and the power, since they are the same. So we take the logarithm of both sides to base a. So this becomes log uh, a, a raised a, then a raised to the power of log x to base a is equals to log um, u raised to the uh, log u to base a. So now you can see that this part here is log AA, and log AA is 1. So, so that this expression here, the whole of this expression will now drop to become log x, become this become log this become log x base a is equals to log u base a. Then because we are looking for u, so we divide both sides by log a. We divide both sides by what? Log a. And if both sides is a, we divide both sides by log a, you will now see that the whole of this expression becomes no log x base a divide log base a log u base a divide log a, and you see that s is equals to what? Equals to u. So we said initially that we said that u is equals to this expression. So it means that this expression is the same thing as x. So once you are here a given logarithm of this nature, the whole answer center on just the logarithm to which you are to be what to be determined. Okay, this is how to find uh, logarithm. This is how to show their proofs. Please, if you like this video, help me subscribe and also share to uh, those within your social media platform. Have a nice time. See you in my next virtual class.